Hello everyone and welcome back to the Udom King Education Foundation Physics Lab. In our last lesson, we looked at the physical structure of a thermometer. Remember that in that lesson, we were able to see why the bore of the liquid in glass thermometer needs to be so narrow and the glass bulb so thin for high accuracy and important for thermal responsiveness respectively. But today we ask a different question. What exactly should we put inside that bulb? Not every liquid is cut out for the job. Today, we explore the 5 essential properties of a thermometric liquid. Let's dive in. First, the liquid must not wet the glass. But what does that actually mean? Imagine 2 tubes. In one, we have water. Notice how it clings to the sides, leaving a messy film behind as it moves. That's wetting the glass, and it makes the thermometer impossible to read accurately. Now, look at mercury. It slides cleanly up and down without leaving a single drop behind. This ensures every reading is crisp and precise. That is exactly what we want. The liquid must not wet the glass. Second, the liquid should be opaque, meaning you can't see through it. Why? Because a transparent liquid, like clear water, is nearly invisible inside a thin glass tube. We need to see the level at a glance. Mercury is naturally silver and easy to spot. However, if we use alcohol, which is clear, we must add a bright red or blue dye to make it stand out against the scale. If not, we won't be able to see it as it moves along or up the tube. Third, a good liquid needs a wide thermal range. By this we mean the liquid should have a high boiling point and a low melting point. This means it should stay a liquid for as long as possible. We want a high boiling point so it doesn't turn into gas when measuring hot water, and a very low melting point so it doesn't freeze solid on a cold morning. This gives our thermometer the power to measure extreme temperatures without failing. For these reasons, for very cold climates, that is temperate regions, alcohol is preferred to mercury, as mercury will easily freeze. Fourth, the liquid should have a low specific heat capacity. In simple terms, we want a liquid that is sensitive to heat. We don't want it to absorb a huge amount of heat before it starts changing temperature, because that will delay its expansion and ultimately moving up or along the tube. A liquid with low specific heat reacts to even the tiniest change in temperature almost instantly. Is the difference between a fast response and a slow, laggy one. Finally, we need high cubic expansivity. Since our thermometer tube is so narrow, we need a liquid that expands significantly for every degree of heat. A high expansivity means that even a small temperature rise creates a large visible movement up the tube. This makes the thermometer much easier for you to read. So we desire a liquid with a high cubic expansivity. So, to recap, our perfect liquid must not wet the glass, be opaque or brightly colored, have a wide temperature range, have a low specific heat capacity, and possess high cubic expansivity. Master these 5, and you've mastered the heart of the thermometer. Keep studying hard, and I'll see you in the next class.
Udom King Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.